So for our video project, we had question number 3. The question was asking, in the circuit shown, which point has a larger voltage, A or B? In addition, what is the delta V? VB will be larger than VA in the given problem. Electricity flows from negative to positive. Since voltage is the potential difference of a battery and electricity is the flow of electrons, then the negative charge will flow towards the positive end of the battery through the circuit. Firstly, the voltage drop across the 3 ohm resistor must be calculated. In total, the circuit dissipates 3 voltage out of the initial 9 voltage from the battery as current flows through the 3 ohm resistor. Therefore, there is a remainder of 6 voltage flowing through the parallel portion of the circuit.
In order to find the voltage that passes through point A, the equivalent resistance of the 10 ohm and 5 ohm resistors must be found. Since these resistors are in parallel with one another, they can be added as they are to get an equivalent resistance of 15 ohms. According to Ohm's law, V equals IR. Since we know that the values of V equals 6 volts and R equals 15 ohms, I can be found by executing V divided by R. Therefore, 6 volts divided by 15 ohms equals 0.4 amps of current flowing through that part of the circuit, containing the 10 and 5 ohm resistors and point A. To find the voltage on the 10 ohm resistor, executing V equals IR once again, V equals 0.4 amps times 10 ohms to give a total of 4 volts flowing through point A. Performing the same calculation for the 5 ohm resistor generates I times R once again, which is 0.4 amps times 5 ohms, equating to 2 volts. Therefore, 4 volts plus 2 volts equals 6 volts passing through the top part of the circuit, which equates to the initial 6 volts that we said were going to come into that part of the circuit.
Therefore, point A has a voltage of 2 volts. As for point B, 6 volts divided by the equivalent resistance of 4 ohms plus 6 ohms, which equals 10 ohms, generates a current of 6 amps flowing through this portion of the circuit. To find the individual voltage of the 4 ohm resistor, multiplying 4 ohms times 0.6 amps equals 2.4 volts. As for the 6 ohm resistor, 0.6 amps times 6 ohms equals 3.6 volts. And this supports the rule that 2.4 plus 3.6 equals 6 volts that were divided upon both resistors. Therefore, point B has a voltage of 3.6 volts. The value of delta V equals VB minus VA, which comes out to be plus 1.6 volts.